A very warm welcome and a very good morning to all of you. I'm Sevandi Gunasinghe.
I'm Anusha Jala. We will be your host for the day. So Sevandi, why are we here today and what involves this session?
Yes, Anusha, we are here on behalf of the Y2N team to welcome all the enthusiastic guests for an exciting project. So, young to niche professionals. Y2N is a new initiative of IEEE Young Professionals Sri Lanka. We will be focusing on providing the required experience to the niche communities in different industrial fields and enhancing their knowledge in the respective areas. We need to inform you all that we have shared our event virtual background and agenda via our Google Calendar invitation to all. You can set up virtual background to our video. We are having a group picture at the end of this event. Please be prepared to take a photo. Anything else to add, Anusha?
Yes, Sevandi. The Y2N Pro program enables a platform for young industrial learners to enhance their knowledge and get more experience specializing in particular niche technologies by learning from its experts in the industry. This program is designed for a small group of people who are actively cooperating in the same professional field or are interested in doing so.
As you all know, our upcoming project is a workshop series and a competition on phaser measurement units titled PMU Design and Applications. Today, we are going to give an introduction to PMU and to educate you about the workshop series, course content, our speakers, and about the PMU design competition, which will be organized by IEEE Y2N in collaboration with the IEEE Power and Energy Society, Sri Lanka chapter, and IEEE PACE Young Professionals Global. Without further ado, I would like to invite Mr. Pme Workshop, the Vice Chairman of Y2N to welcome the gathering.
Pme is an undergraduate of the Department of Electrical and Information Engineering at the University of Ruhuna. He is the Vice Chair of IEEE Student Branch, University of Ruhuna of term 2021. He volunteered as publicity lead in Y2N in the year 2021. He also volunteered in PES Global Student Congress as a publicity team member in the year 2020, PES Day Ambassador 2021, and IEEE Day Ambassador 2021. Pme is currently volunteering as the Vice Chairman of the Y2N project and leading the PMU workshop and competition. Mr. Pme, over to you.
Thank you, Anusha. Good morning, ladies and gentlemen. Today, on behalf of the IEEE Young Professionals Sri Lanka and the organizing committee of IEEE Y2N I warmly welcome all of you to the awareness session on the PMU workshop series. First and foremost, I would like to take this opportunity to express my gratitude to the enthusiastic audience for joining us amidst the power cuts and ongoing crisis in the country. As you already know, Young to Niche Professionals is a new initiative of IEEE Young Professionals Sri Lanka, focusing on improving the experience and knowledge of niche communities of various industries. After the successful conclusion of our first workshop series, themed It's All About PMU, we are gathered here today for the next step of our journey. Today, you will witness the commencement of the PMU workshop series, which is undoubtedly be a timely topic with the present power crisis in the country. I am honored to welcome our keynote speaker of the day, Dr. Anton Hettiarachchige, Senior Lecturer in the Electrical and Electronic Engineering Department of Sri Lanka Institute of Information Technology. I would also like to take this opportunity to welcome the Executive Committee of IEEE Young Professionals Sri Lanka, chaired by Mr. Dhammika Mahasinghe, members and volunteers. IEEE Young Professionals is a group of IEEE members and volunteers who have graduated with their first professional degree within the past 15 years. It's an international community whose members are interested in elevating their professional image, expanding their global network, connecting with peers locally, and giving back to their community. IEEE Young Professionals Sri Lanka was established in October 2011 and has been striving for the betterment of young professionals in Sri Lanka ever since. It aspires to be the leading professional network for young professionals and industry in Sri Lanka. It hopes to increase the participants of industry members and build community recognition in the industry to attract fresh graduates and provide them with those benefits. IEEE Young Professionals Sri Lanka has been growing steadily for more than 10 years and has so far launched several project names: Stood Pro, Let's Talk, IEEE Innovation Nation Sri Lanka, IEEE SL Inspire, AI Driven Sri Lanka, and of course Y2N Pro. I would like to also welcome the organizing committee of IEEE Young Professionals Sri Lanka, headed by IEEE Young to Niche Professionals, headed by Ms. Kaumadi Gunatilaka. Y2N Pro is a recent initiative of IEEE Young Professionals of Sri Lanka. It primarily focuses on deep and niche technological learning, which are not covered by typical tech talks. The Y2N Pro programs promote a platform for young industrial learners to enhance their knowledge and gain more experience specializing in a particular niche technology by learning from experts in the industry. These workshops or short course organized are aimed at delivering expert knowledge starting from the very basics. These are also structured in a way that not only theoretical knowledge but also hand-on experience is delivered to the participants. Y2N Pro was launched in October last year with the panel discussion theme Gravity of Proficiency with Professionals. The first workshop series, It's All About PME, was conducted focusing on MRI in the biomedical engineering field. After the successful conclusion of this first series, we are virtually gathered here today to launch our second workshop series on the phase measurement units. I would also like to extend my gratitude to the IEEE Power and Energy Society of Sri Lanka for partnering with us, and I would take this opportunity to welcome the executive committee chaired by Dr. Sudhira Navaratna, members and volunteers. The IEEE Power and Energy Society of Sri Lanka is one of the most active chapters in the country, with membership ranging from students, academia, and researchers to electrical engineering working in the industry. The society chapter strives to bridge students and young professionals with the most senior members of the field and provide a platform to collaborate and network while setting up a healthy environment to enrich the power and energy sector of Sri Lanka. I would like to express my gratitude to the IEEE Power and Energy Young Professionals for collaborating with us by granting the IEEE Best Ignition funding. Last but not least, I would also like to welcome the enthusiastic audience who joined us amidst the power cuts and ongoing crisis in the country. I wish that you will give us your fullest support in conducting a successful workshop series and a competition. I would again like to extend my gratitude to everyone here for your enthusiasm in the workshop series and hope you will take a maximum out of today's awareness session. Thank you and have a good day. Over to you, Sevan.
Thank you very much, Mr. Pme, for insights on PMU design competition and workshop series as well as YP Global.
Next up, we have the most awaited session.
What is it?
The keynote speech. So, without taking much time to continue the session, we would like to introduce and invite our guest speaker, Dr. Anton Hettiarachchige, to share his expertise on PMU with our enthusiastic audience.
Dr. Anton Hettiarachchige Don is currently a senior lecturer at Sri Lanka Institute of Information Technology in the Electrical and Electronic Engineering Department. He has graduated with a PhD in electrical engineering with a focus on power systems from Wichita State University in Kansas, USA. He has completed his bachelor's in engineering technology at Southeast Missouri State University and his master's in electrical engineering also at Wichita State University. And his area of research is in advanced wide area monitoring of the electric grid system using new age measurement technologies and algorithms. Please welcome Dr. Anton Hettiarachchige. Dr. Spotlight is yours.
You are muted.
Sorry. Okay, so good morning, and thank you very much for that introduction, and good morning to all the participants as well. So let me, I can start sharing, right? Yeah, that should work. All right. So I think throughout the session today, you will get more information regarding the layout of this workshop that has been planned and what content is going to be covered. So I'm thinking that I know that that's going to go deep into the capabilities and functions and applications of PMUs. So I'm not going to get into that. But what I'm going to do instead is going to give you a brief introduction to PMUs, showing you a big picture of the capability of PMU, a little bit of introduction to its history, what kind of things we are expecting PMUs to enable going forward in our power grids, and basically get you interested in this technology. And I think it's very adept that we are talking about such a niche technology in this forum, which is focused on niche technologies. And yeah, and I'm thankful for giving me the opportunity to talk about this. So to get started with, yeah, So as I have already been introduced, I don't want to spend time on this. My name is Anton, and I am currently a senior lecturer at the Sri Lanka Institute of Information Technology at SLIIT in Malawi. And my area of research is in power systems primarily. And that means that at this time, we are focusing on smart grids, renewables, renewable integration, and very specifically, my area is in advanced monitoring of transmission lines. And as you will see over the next couple of minutes, that this is squarely where PMUs fall under, right? So I completed my PhD at Wichita State University back in 2021. And I finished my bachelor's at Southeast Missouri State and master's at Wichita State as well. So talking a little bit about Wichita State University, we are a member of the Power Systems Engineering Research Center in the United States called PSERC. It is a collection of, I believe, 13 universities that cater towards industry needs. So we work with industry partners. In this case, it will be utilities, power utilities. And we cater to their requirements. We try to solve problems, basically, that they have. So what that means is in this area of PMUs, we were tasked with working with PMUs and seeing how they can get the best output from their investment in PMU networks. Now, if you don't, if you are very new and you don't even know what PMU stands for, don't worry. I will go over the very basics and we'll start from there. So a key thing here was that, as you'll see later on as well, that PMUs were not, well, they started to be widely adopted very recently within the last 10 years. So what happened was, as part of this PSERC community, we were given opportunities to see how new implementations can be done using PMUs. So I think that was a good, good opportunity to extend our research capabilities. So Wichita State was also a forerunner in renewable technologies. Starting way back in the 1970s, we had the Center for Energy Studies, and we still do. So 1970s means, the time of coal and gas. No one was thinking about renewable technologies, but the professors that we had at Wichita State University at the time saw what was happening. They started doing research. At the time, it might have not been accepted because people are not very concerned about renewables, but we have been doing research in renewables since the 1970s. So, Wichita State has a very established power research arm. So I'm going to start by talking about a little bit into the history and seeing how this need for PMUs and smart grids in general came to be. So I'll take an example. You may or may not have heard of the Great Blackout of 2011, right? So September 8th, 2011, in the southwest region of United States. So that means the area covering Los Angeles, California, state of California, cities of Los Angeles, San Diego, and then also the states of Arizona, Nevada, Oregon, New Mexico, and all of that, right? So a technician, while doing routine maintenance, accidentally shuts off a 500 kV transmission line, right? Okay. So this transmission line, and if, as you know, a 500 kV is a major high tension line, that means it is carrying a lot of power. So by accident, that a part of that line gets shut down. Okay. So the point here is that that line was carrying a major portion of the power from the state of Arizona into California and into the San Diego area. So the city of San Diego is down here in the south, right here. So a major portion of the power for that city was carried through this line. Okay. So what happens when one of the lines go down? Well, the system readjusts, right? Power has to flow somehow. And since this is a well-connected system, it's a web, power gets rerouted and it starts flowing from all around and somehow trying to get to the San Diego area where the load is. Now, it doesn't have the major part, but it will try to get there somehow. One of the points that it tries to get through is the Onofre nuclear generating stations switchyard, which is like a substation connected to the nuclear power station that is right here, just north of San Diego. Okay, so a major portion of the power gets rerouted and it starts flowing through that substation. What happens is that this substation quickly reaches its limits. Its safety limit is reached fairly quickly. But that is still not enough. What happens is more transformers start going offline around the area where this issue is, because they too are getting overloaded. And in the end, the power flow through that substation hits 170% of its safety limit. So all this is happening within about 10 minutes. Okay. So 170% is reached. There is a little bit of time, I believe, until it's, before things start to safety actions start taking place, but nothing is done. And then the automatic systems take control and it shuts down the power flowing south of there. So the power flowing south of that switchyard going into the San Diego area is shut down, right? It's a safety mechanism to safeguard the transformers and generators at this switchyard, right? So what this basically creates is 3 disconnected islands. Now, if you are not familiar, an island in power systems, an island is when a small area within the power grid becomes disconnected from the rest of the grid, so it can start on its own, or it can act on its own rather. So this is by design, it is designed to do this. But the problem is the generation within that island itself is not enough to cater to its load. So then another thing that happens is load shedding starts taking place. That means certain big loads are taken offline so that the generators within those islands are able to supply the load. But all this happens fairly late. It takes time. So what happens is the frequency goes down and the generators shut off. And within 10 minutes of this whole thing starting, all three of these islands are they go into blackout, as in they lose all power. The generators shut down, they're not connected to the rest of the grid, and it's a total blackout, right? So this blackout leaves nearly 7 million people without power, right? And this is a CNN screenshot from the news program back in 2011. You can see the only lights you see are from the vehicles on the freeway. So, and this blackout is sustained for several hours until parts of the system can be reactivated slowly. Now, of course, talking at this point of time here in Sri Lanka, this doesn't seem too bad because we are experiencing this nearly daily. But a blackout is something that almost never happens basically in developed countries. So as an example, in my time, nearly 10 years in the United States, I experienced one blackout. That was during an ice storm. So because of the ice storm, some of the power lines came down, and that lasted maybe 2 hours. So for the whole 10 years that I was there, I lost power for 2 hours. That's all. And it's a bigger problem than most people would realize over here. It's because over here we have backup systems, like even before this crisis, most major retailers, companies, offices, they had their own generators standing by because blackouts were fairly common, right? Once a month, maybe twice a month, we would get it. And then our crucial things like our airports and hospitals, they have backup power by design because we do expect this. But the thing is, in United States and a lot of other countries, they don't have this because they don't expect blackouts. Hospitals sometimes do, but things like retail shops and offices and all these places, they don't have backup power systems. Even our street lights, traffic lights, they don't have power backup systems because you never expect the power to go off. But on this day, in 2011, everything goes off for nearly 7 million people, encompassing several cities. And this is sustained for several hours. Okay, so this is an example of a blackout that happened back in 2011. Now, why couldn't this be prevented? Okay. Why couldn't some action be taken to prevent this? This point has been the subject of many, many reports and research studies for many years following this incident. People have been researching this, doing studies, and trying to figure out what happened, what went wrong, and why couldn't we prevent this. The point here being that the technical issue or the start, which is a human error, a person turning off part of the transmission line, that might not have been able to be prevented. People make mistakes, that's fine. But what happened after that? That should have been isolated, that should have been taken care of. But why did it cascade into this big failure and we were not able to stop that? That is where the research is. Okay, so a lot of reports came out. The government itself did its own study on this. And one of the common themes was the lack of sufficient system observability. Okay, so enough observability to take timely actions. That is the main point. We did not have a good enough overview of the system in real time. So as an example, this video that I'll play right now. So this was done, of course, post-mortem. That means this is from the data collected. So this was not available in real time. But the point here is you can see things starting to go wrong. Okay? You can see things starting to go wrong. So let me play it. And I'll pause it in a bit. Okay. So what we are seeing here is the system frequency. Okay, so system frequency is sort of a good indicator of the quality of the power, or the how well your system is system is balancing its load versus its generation. So what you are going to see, oh, by the way, so in the US, it is 60 Hertz, right? The system is 60 Hertz. So it should be at 60 Hertz. It can slightly vary, but it's supposed to be at 60 Hertz. So you can see right now, and 60 Hertz is blue on this map. And you can see on this plot that it's at 60 Hertz, everything is fine. You can see within a few seconds, actually, there's a drop. You can see where the drop started, right? Down south, sort of southeast of this map. You can see there is a drop happening. So the system-wide frequencies drop. So why is this system-wide frequency dropping? The frequency is dropping because now there is an excess of load and not enough generation. Why? That power line went down. So there is not enough power coming into this area, but the load is as it is, right? So this system frequency drops and it stays in that low value, 59 something, for quite a while. Now, when I say quite a while, it's a few seconds. So that's the main point here. It's only a few seconds. So the system should be able to catch that within that few seconds. But of course, that was not done. And you're just going to see what happens next. During this time, the generators and the lines that are taking over or acting as a backup are getting overloaded because they are heating up, because they are carrying that excess power. And soon things are going to start shutting down. For their own safety, they're going to start shutting down. The automatic shutdown procedures are going to take place. And you can see, boom, there's a huge increase in frequency. The whole map changes immediately. So why did that happen? Well, that's because a major part of the load was lost. And now there is, of course, excess generation. So the frequency is going to jump. So you can see this very nice map. You can see this very nice color coded map showing exactly the frequencies and all of that. Now, this was, like I said, done post-mortem. That means after the event, right? Now, had this been available at the time, had the operators and the automatic decision-making software been available at this time that had this information, was able to see a map like this, this could have been prevented, right? At the beginning where the frequency starts to drop, immediately action could have been taken to shut off some of the load so that the system frequency comes back to 60. But of course, that's in hindsight. We didn't have the technology to have this kind of map, this kind of nice data available to the control center at the time, right? So the system lacked the observability, the real-time observability that was required. So that is one example that I wanted to go through, just to give you an idea about the background behind that necessitates the PMUs and the implementation, right? I'll give you a few more examples as we go along. I believe there was a raised hand. Was that by mistake, or do you have a question? Of course, if you have any question, you can, of course, raise your hand and ask me. Any? Okay, probably that was a mistake. That's fine. Okay, so so that is one example, right? I'll give you one more quick example. Another blackout happened in 2011. Oh, 2003. Sorry, I didn't change it. This is in 2003. The Northeast blackout of 2003. Right. So this struck the northeastern region of the United States as well as a little bit into Canada, because the systems are connected in Canada and the United States. This was due to a software bug in one of the stations, or one of the control centers actually, that disabled some alarms that were supposed to tell them when the system is getting overloaded so that corrective action could be taken. Now, again, that incident of that initial incident, we may not have been able to prevent. But what we are more focused on, why we couldn't localize this, as in why we couldn't shut down just that small area and prevent this from spreading to like a large portion of the country. And of course, it wasn't, right? The system-wide observability was not there. We couldn't take corrective actions in time. The signs were missed. And you can see in this light map at the bottom, it's missing, right? The usual light maps that you have seen before, there would have been lights all in this area. This is due to the blackout. Again, they don't have backup systems like we do here because they don't expect blackouts. So when there is a blackout, everything goes off. This is in New York City, so a huge population, the subway systems, the traffic lights, even the airports, like except for the critical functions, even the airports would go offline. So this is a big event, right? So again, post-event analysis was done. And what they saw was a clear voltage angle divergence between two adjoining sectors, right? The voltage angle between two sections should be close to one another. But what they saw was the voltage angle difference between the Cleveland area and the Michigan area starting to diverge. You can see it is less than 20, which is where it's supposed to be. And then it's starting to diverge over several minutes, nearly an hour. And this line is where the blackout strikes. The system is not able to maintain itself because of this voltage difference anymore, and it starts shutting down, right? Safety procedures start taking place. But before that, for nearly an hour, the signs are there, right? But it was not something that was monitored. This, in real time, we were not monitoring the voltage angle difference between these two sections. That data was not available to us. And what that means is this was not caught. The signs were missed. So again, this is an example of not having system observability, right? So these kinds of blackouts were fairly common. I mean, even they are fairly common. But the point being here is that our actual number of what has happened is the amount of power that we supply has increased a lot, but the rate of blackouts have stayed nominal. So if you take the rate of energy that we are providing, there is an improvement. This is an example of a few of the blackouts. So you can see it's fairly common, not just in the United States, but everywhere around the world. There are these catastrophic blackouts that are preventable had we had clear real-time information before the event, right? These blackouts are fairly common, especially in the summer months, because that's when the load is highest, right? All the air conditioners are running. That's when the load is highest. And this tend to be where most of the blackouts happen. You can see around June to May to August, right? This is where the most common time for blackouts. Right? Right. So now, events like what we talked about just now, these are what help drive what we now call as the smart grid agenda, right? You would have all heard about the smart grid. Everyone's talking about smart grid. Everyone's doing research on the smart grid. So it is events like this that pushed us towards smart grid. It interested the politics and the government on smart grid. It interested the utilities about the power grid regarding the need for a smart power grid, right? So a major point within this smart grid is enhanced real-time system observability. It is being able to see exactly what is going on in the system in real time. So what this allows us to do is to run the system more efficiently, more effectively, have higher resilience, reliability, and interoperability. I'll talk about these later on specifically, but these are the main benefits that you get by having good system-wide observability. Right? So now, with the advent of renewable energy, right, the main point about renewable energy is that it is intermittent, and I'll talk about this later on as well. This system observability is even more important, and you'll see why. Okay. Now, at the transmission level, this is largely due to PMUs. This observability can be obtained through the use of PMU networks. Okay, so that's what we're going to be focusing on, which is the transmission level. So the smart grid as a whole, what it is doing is combining three separate infrastructures together. We had our traditional power grid, right? This is our power system. This is the cables, the transmission lines, the transformers, the generators, the loads, all of that. That is the power grid. But What we are putting on top of that is a range of sensors and communication devices that allow us to look at the power grid and take decisions. Now, the decisions are taken at the software and application level. So these are the three things that we are combining together to create the smart grid. Okay, that's what a smart grid is, the combination of the power grid that is already existed for a long time, the sensor suite, and the decision making and application capability. So combining these together give us the power grid. Right? So what the utilities do is they install a wide range of smart devices. So some, for example, the smart meters that even in Sri Lanka they are starting to install, PMUs, HVAC systems. These are these temperature, like in your house, the temperature of your house can sometimes be controlled by the power grid or the utility, so that if there is like they need to do a little bit of load shedding, they can reduce your AC a little bit within a few degrees, so you wouldn't really notice. But if they can do that for like a large number of customers, then of course they will see a significant drop in their power load, right? So that is also something that is actually being done right now, right? So these kinds of the sensors that they install on the system to enable this smart grid. Now, going back to our area, which is the transmission line, this area, right? The transmission system that is taking the power from these generators into the distribution side where the load is. So this is where we are focused on. So again, we already had sensors, right? Most substations have sensors that are able to take this data and they shoot it up into the cloud through some network, and they show up on our control centers, right? They have big screens like this where the data that is being taken up by these sensors show up. And what they use for this is something called remote terminal units, okay, or RTUs. Now, what is happening is that the system is changing. For example, we are having these solar farms being installed and other renewable energy sources being installed. What's happening is that our system is becoming more dynamic, right? In fact, by 2019, the amount of power generated through renewables surpassed what was generated by coal. There's been a huge reduction in coal usage over the past decade or so. So the amount of renewable energy actually surpassed coal. So where's the problem? That's good, right? Renewable energy is good. It's good for the environment. It's good for everyone. But what is the problem here? The problem is that renewable energy is intermittent. What that means is we have very little control in terms of how much power it is producing. For example, in this plot, you can see the green line is our energy demand, right, for a particular city, right? This is our energy demand. Now, if we know this, and if we have, let's say, a diesel power plant, we can, like, diesel power plant, it's sort of like your car. You can accelerate it and you can produce power as needed, right? To match this load, we can produce the power. Remember, the power has to be produced to match the load, right? We cannot have excess power in the system. It's not like your the water drainage system where you can have a water tank. Electricity doesn't work like that. It has to match. So the problem here is you can see the solar generation. We have no control. It depends on the sun. And you can see as the sun starts to rise, it's going to increase and it's going to hit a peak around noon, and then it's going to come down. And wind is even worse, right? Wind, you have absolutely no control over, and it's very difficult to predict. In the sun, you can sort of predict, right? Unless it's cloudy. But wind is very difficult to predict. So you can see wind generation is all over the place. Now, this wasn't how the system was, right? When you had coal and diesel and natural gas, you had very good control over how the system operates. Now, we no longer do. We need our system to be dynamic, to be able to see these changes and react to these changes. So for this, we are using synchrophasor measurement units, or we are replacing our RTUs with PMUs. So if you're confused by the name PMU, it's coming from this phasor measurement unit. They have the synchro part in the front, but it's synchrophasor measurement unit, but they write it as PMU, right? So why are we doing this? What benefit? So I'll give you an example. This is a voltage fault issue that was recorded in the utility that we were working with actually. And I'll let you guess what the two lines are, right? So one of them, the black line, you can see it sort of follows the issue, right? But not really. I mean, if you're taking a very good look at it and you're keeping watch, you can sort of see something is wrong. What about the red line? It is going crazy, right? Because that is giving us the real situation. And as you can guess, those red lines are the data from the PMU, and the blue line is from the old RTU or SCADA system that we have in our traditional power system. Now you can see a huge improvement. Okay? So the visual improvement that you see here is the refresh rate, right? It is how often we are getting a new data point. PMUs, the new technology, they measure about 30 times a second. Now this graph is a little bit older. Right now we have PMUs that can do 60 and even 120 times a second, right? So that means with several times within a power cycle, right? If you have a 50 or a 60 hertz system, that is, it takes measurements several times per power cycle even, right? Whereas the old SCADA system, it will only update every few seconds. So you miss some events, right? So that is the major benefit that PMUs give us. But that's not the only benefit, and I'll talk about that later on as well. This is the most obvious or visually obvious benefit. So the traditional system, the way it works is you have your potential and current transformers at substations. They take in voltage, power, and reactive power data about 4 seconds, every 4 seconds. Older ones do about every 10 seconds even, right? And then they send it to control centers via microwave or using the public network or whatever method the utility is implemented. And they are showing up on the energy management systems, right? That is the traditional system. But PMUs are changing this. Now, the main problem here is that in the traditional system, it is not real time. What I mean by this is, if you are getting updates every 10 seconds, that means by the time that you see something, what you're seeing is actually what happened about 10 seconds ago. So dynamic incidents don't show up very well. If the system is rapidly changing, right, within microseconds, that is not going to be shown up on your system. So we don't have real-time situational awareness of the system. But here, so that is obvious, right? You saw that from the plot. But here's something else that you might not have thought about. The sample times may be different at each location. What do I mean by this? And we'll give you an example in a bit. Okay. So the problem with this is that you cannot compare. It's difficult to compare data coming from two different geographic locations. Actually, comparing them might not be accurate, right? So I'll talk about how PMUs solve this. So synchronous measurement units, or PMUs are for short, is a cutting edge technology that has been implemented in transmission level, right, for power system observability. So a well-developed network of these provide utilities with multiple information streams. So they have their SCADA system as well as the PMU system. So, and the PMU measures a lot more things. So it gives you a very detailed outlook. Time synchronized data, you know exactly when things are happening, right? A very high sample rate. So 30 is the base. Now we are getting 60 and even 120 times a second. So it's sort of like going from an X-ray to an MRI. You would have, you know what an X-ray is, right? It's just an image about of your insides, right? Your bones and stuff. Whereas, have you seen an MRI? If you haven't, you can just YouTube, like watch YouTube video, what an MRI looks like. You can actually go into the flesh at different, it's like a 3D image, and you can take different layers. So it's like a whole new dimension, right? So installation of PMUs, it's sort of going from an X-ray of your power system to looking at it through an MRI. So it's a huge improvement, right? So because of this, worldwide utilities were very quick to adopt this technology, right? So if I take the United States as an example, that's where I'm most familiar with. By 2015, they have achieved 88% of the country's power load, right? So 88% of the power that is flowing within that country is being tracked through these PMU networks. And this is 100% of the high voltage lines. So they're only missing a few low voltage lines. 100% of the high voltage sections are covered through PMU, through these PMU networks. And then how these PMUs communicate is through, they have this structure where you have PMUs, they are connected to a set of what we call PDCs, or phasor data concentrators, that is able to connect through multiple PMUs. And then they go up to a regional PDC where everything is collected together. At each of these points, the data can be given out to the interested parties, which are the utilities in that region, right? So for that map that I just showed you, this is what it looks like. You can see the lines show you how the networks are connected. Now you might ask, why is the blue side not connected to the yellow side? Well, actually, in the United States, it's not one grid. We actually have 4 grids, right? They are connected through DC lines, so the frequency issues don't really matter, but largely they operate on their own, so they don't actually have to be connected, right? So that's what the 4 colors here represent, the 4 different networks in the North American region. But you can see if you take the blue side, which is the Pacific side, where like California and Nevada area is, you can see everything is connected together. Each of these blue dots are multiple PMUs connected, right? So give you a little bit of historic perspective. I won't take too much time for this. This was done in, so what happened is the 1890s, people were doing research, and one of the papers was this mathematical techniques for AC network analysis. This gives us the base for phasor measurements in the AC network. And then this idea developed over time to the PMU measurement technologies that we have now. And this was only possible after the development of, or the advancement of electronics. We have good enough microprocessors. We have the GPS system, which I'll talk about as well. So many things had to come together before PMUs as they are right now was possible, right? So the first PMUs were developed at Virginia Tech, right? It was funded by a number of electrical utilities in the United States. So in the United States, we don't have one, we have multiple private utilities. So a bunch of them got together to work together with Virginia Tech to develop this. It was spearheaded by Professor Arun Padkhe, who was the lead person in this. And then it took about a decade. And the first prototypes were installed on the Bonneville and New York Power Authority areas as a test phase. And this is the first commercial product that was available by a company called Microdyne. It was available in 1990, right? I'm not sure whether they are still available right now. Most of the PMUs, that at least the ones that we use, are from SCL, right? So fundamentals about the PMU, there's basically 2 types of PMUs. We're not going to get into details, but we have what we call as the P type, which is for protection, and we have what is called the M type for measurement. So the P type has a faster response rate, but is less accurate, because you don't care about accuracy. You want a very fast response to take protective actions. Whereas a measurement, you are more concerned about getting an accurate value. So those are the 2 types. So what they do is they give out a bunch of information, right? The main things that PMUs report is positive sequence voltage and current magnitude. So the magnitude of the voltage, magnitude of the current, the phase angle of the voltage and phase angle of the current, the local frequency, the rate of change of frequency within its sampling time, and utilities can configure to like transmit other things like their circuit breaker information and switching state things also, but that's up to the utility. The main things is the voltage and current and frequency, where the voltage and current are given as phases. That means the magnitude and the angle, right? So this is how it is installed into the system. They use the existing measurement infrastructure. So the PTs, or the current transformers and the voltage transformers that are already on the system, that's what they would use, right? So you have the phase conductor coming in, you have your potential transformer, the voltage transformer, that is connected through. So you get a voltage from that. You get your current transformer, and that is connected through, and you get your current output from that, right? All that information gets fed into the PMU, right? So they use the existing voltage and current transformers. And then you also have a GPS antenna within the PMU. This gets its GPS signal, and I'll talk about what this signal is. And then using the GPS signal, they put a timestamp on this information and they transmit it out through their communication network. So that's essentially what the PMU does. The point here being that it is able to do it at a very fast rate compared to the traditional system. That's one of the advantages. The second advantage is I hinted at, I'll get to in a minute, right? And this does it many times a second. Now, talking about this GPS. Now, what you are most familiar when I say GPS, you're thinking about navigation, right? But that is not the only thing GPS gives us. Even your phone. Do you remember back when you had the old like the Nokia phones? It would ask you to set the time, right? If you notice now, you don't have to do that. The time is already there. Even if you don't have data or your SIM is not connected, you still get accurate time. So how is it doing that? Of course, like your telecom, like your Mobitel or dial-up, they gives you time as well. But even without that, your phone knows exactly what time it is. A very good example of this, if you have a newer car, you don't have to set the time on your navigation system or your clock in the car's clock. You don't have to update it anymore. Why? Because your car, if it has a GPS system, if it has a navigation system, it already knows the time. So time, or very accurate time, is something that GPS gives us. The GPS signal contains very accurate time information, and it's accurate to it's accurate to 2 microseconds. So this is what PMUs use. So the point being is that because it is transmitting this data containing the time that the data was taken at, even if there is a communication delay, we can put that, or we can use the time tag to place the data correctly at the receiving end, right? So the PMU doesn't report in continuous time, right? It's not a continuous time reporting. What it does, it sends out packets of data at a particular rate. This is called the reporting rate, right? So what it does, it takes a large number of samples within the reporting rate. So if you say 30 times a second, but to achieve that, at every 1/30th of that time, it takes multiple samples and then combines them through some complex algorithms that you will learn about later when you do at the workshop. It takes that, do some mathematical calculations, and it sends out a signal, and it does that every 30 times every second, right? So it takes multiple measurements, combines them, and put a time tag on them, and then sends it out, right? And it does that 30 times every second, or even 60 times or 120 times with the newer systems, right? So this exact algorithm that it uses is sort of up to the manufacturer. And one thing about this is that it is very susceptible to frequency changes. So it is important that the system is has its baseline frequency. If the frequency changes a lot, this can affect the accuracy. This is an issue that I'm not going to get into. This is an issue that has a lot of research behind it right now. A lot of people are researching how to fix this issue, and it's not an issue that we fixed. It's still perfectly fine, but how we can improve it even further. So that's a very interesting area of research, actually, right? So the IEEE standard C37.118 is the standard that governs the function of PMUs and their communications. Very recently, this was adopted into a larger set of standards, but the content is the same, right? So the number is slightly different, I think. So what the standard tells us is the minimum accuracy levels that should be maintained by the manufacturer, as well as the reporting rates that I mentioned before. So the reporting rates, you can see for 50 and 60 hertz, you have these set reporting rates. And I believe even for 50 hertz, now you have much faster PMUs, right? The information here is slightly older, but of course, it's always going to be improving, right? So what we see a little bit of an issue with PMUs is that when the frequency of the system vary away from the normal or the nominal value, the error between what is actually there and what is estimated can increase. So that is an area, a very interesting area of research. Okay. But according to the standard rather, you have to maintain what we call as the total vector error. That means the total error as a phasor should be less than 1%, right? The error should be less than 1% as long as the system is within 5% of the nominal frequency. So a manufacturer has to be able to prove this before it is able to provide PMUs with the IEEE standard, right? So this issue of this error or TVE is the square root of the square difference between the real and imaginary parts of the the measured and the actual value. So there's an equation to calculate this as well. I'm not going to get into this because you will probably learn about this when you take the workshop and you see the insides of the PMU, the mathematics behind PMUs, right? Okay. So getting back to things that might be a little bit more interesting, I'm going to talk about that second advantage that PMUs give us that might not be directly obvious when we look at PMUs or that data that we get from the PMU. So remember I talked about we are getting data from all these different locations. Like you saw that map of the United States, right? Everywhere around the United States, they have these PMUs connected. But we are able to basically, 1 second, let's make sure I'm within time. Yeah, okay.
Yes, no issues.
Okay, no, just sure I'm on track. So the main other advantage, now let's say you have a system, okay, you have a bus X and a bus Y and you're getting data, okay, that's fine. Now this data that you're getting from bus X tells us that at 5, t equals to 5, the value was this. And bus Y is telling us that at this bus, at t equals to 5, the value was this, right? Some value like 0.8, let's say, and here it is about 1. Now the problem here is, how do we know that the value of t equals to 5 here is the same as t equals to 5 here? We don't know that. Now that is the other main thing that is solved through the use of PMUs, because PMUs use GPS, which is a global timekeeper, and it is using that timestamp to send out the data. We know exactly that at t equals to 5, both these locations are telling us a particular value, and that is exactly at t equals to 5. So what this allows us to do is you can combine data coming from all around your geographical PMU network without worrying about the times being off. So that is the second major advantage, and that's a huge advantage that sometimes it's not easy to comprehend, but that does give you a huge advantage because you can use data from all around or from a large network together to do your state estimation things. Okay. So GPS time tag, like I said, accurate to 2 microseconds, and it's updated every second. And then it uses the phase lock oscillator to generate the signal or generate the time tag that is based on universal time, right? So I'll give you some examples about what this data actually looks like. So I'll take an example here from this data that actually I worked on. I blurred out some names because I can't, according to the NDA, we can't tell you who we are working with. So this is from a 3-phase line, 340 kV line, about 20 miles. Okay. So through a voltage transformer and current transformer, and it has an SCL 421 PMU at either end of the line. Right, this is what a PMU looks like, hardware to hardware. So the data arrives in it's in their own very proprietary format, in a compressed format. But we can decompress it in their own software into a .csv file, and this is what we get. Again, I blocked out some information, but this is what you get, a whole bunch of numbers. You can take it into Excel and kind of make sense of it, but this is what it basically gives us. The timestamp shows us very accurately we are getting the data. Terminal ID, PMU, and here you can see VMS is A, and then VA is a phase angle for voltage in phase A. Same with current for phase A, and then for phase B and phase C, and then you have positive sequence for phase positive sequence values for voltage and magnitude. You have your frequency, your rate of change of frequency, and other like digitals and statuses that the utility is giving out. So you can see this is the data. This is the actual phasor data that the PMU sends out. I put it into an Excel file so that it's easy to see. This is what it is sending out. Now you can see, and you can see, imagine this is sending it out for every PMU 30 times or 60 times or 120 times a second. You have a huge amount of data at your hands to work with. And that gives excellent system-wide observability. It usually comes into a software like this, which will update in real time. But if I show a bunch of data that we got, so this is some current data, this is some voltage data, and this is some frequency data. So you can see very accurate. You can see how fast it is changing, right? It's a very squiggly line. That means it is updating at that speed. Now, this is of course not real data. We recorded it and then I'm just showing you. But in real time, you can get data that is updating at that same speed. Okay. So now what can we do with this? Now that is the main thing, right? Now we have this data. Researchers were quick to jump into figuring out ways we can use this data, right? So this is the area, big opportunity for researchers, right? So people work with utilities and a lot of things have been proposed. Some of things are being researched. Some things have already been implemented. So basically you can break it down into 3 areas, which is contingencies. So contingency, well, let me talk about it. So contingencies is day-to-day operations, as in fault analysis. Now, how you can figure out if a fault is happening, how to quickly catch that, right? If a line goes down, how to reroute power around without causing issues like we saw in the previous blackouts. So those are contingencies, so real-time actions that can be taken. Then you have a day-ahead planning and short-term planning. These are things like, now tomorrow, can I rely on this power plant to give power? Looking at the fact that the power line that is taking power from this power plant to the city, will it overload or not, if it's allowed to carry? Remember, the power lines can overload, right? But if you have real-time information, you can know whether or not it will overload based on historical data and based on other things. Now, those kinds of day-ahead or very short-term planning can be done. So that's another area of research. And then you have long-term planning. That is expansion. You can think about whether or not you need another power line. So you need another parallel power line because you can see your power line daily, it's about to hit its peak. So you can take long-term plans as to let's build another power line parallel to this to take care of this issue. So things like this. So all these different areas of power system planning, PMUs give us a lot of information to, right? So this is again a little bit older, but you can see all these different types of applications, and you can see different countries are already implemented them. They are under testing, or they are under planning stages. And of course, it's a little bit older. Probably most of these are already implemented in all these countries. So that is where we are right now. So let me talk about why we can make use of this as well. Got a bit of time. So now what about us? We have agreed to certain global climate change goals, and we are supposed to be focused on building power, renewable power, right, for future energy needs in Sri Lanka. But however, the issue we have is a large portion of this power that we can build in the future is going to be located far away from load centers. And this is to make use of our natural resources. For example, our wind is located in the north and in the center, right? Our solar is located at the south, or high irradiance is located in the south and in the north. Hydro is located in the center. But the problem is our population is centered around Colombo and a little bit around Kandy, but mostly around Colombo, right? That is where the population density is. Now you can see these maps don't match up. Right? We need to take power from where it is generated to where it is needed. This means the power has to be transported. Now at present, the Sri Lankan power system or the power transmission system is very radial. If you saw that map I showed you about the United States a little bit earlier, it was a web because everything is interconnected. In Sri Lanka, we don't have a lot of interconnections, right? So if a line goes down, the line goes down, right? That area loses power. So either we need to change this or we need to make sure that these lines don't go down, or we increase the reliability of these lines. Now, the best way to increase transmission line reliability is through the use of PMUs. But why? Why is it not done? Mainly, it is a cost factor, right? A single PMU can be very expensive, just the device, but that's not the point. Analysis show that actual device is only about 5% of the cost. Why? Because it needs a lot of other things. So excluding labor, you need to think about a communication system. You need a high-speed, reliable communication system that connects to all these remote locations, right, where PMUs are located at. You need PDCs and other infrastructure for the network. You need security because now you are transmitting through the internet. You need cybersecurity infrastructure. So all these things add up, and the actual physical thing, although it's very expensive, cost that's only about 5% of the cost, at least in the analysis done in the United States. So in 2016, an installation of a single PMU cost about 43,000, and of course you can guess right now it would be much higher, right? And also there is no economy of scale, as in when you want to install 1,000, it doesn't make the per PMU cost any lower because of the way it is. There is no economy of scale in this. And to be efficient or to make good use of your network, you actually need a lot of PMUs. You cannot have a good observability with a single PMU. Each critical line would need 2 PMUs at either end, and they would have to be all connected together for multiple lines to get good observability. Right? So cost would be immense to do this. But here's the point. It would be very essential, as in it's something that is highly essential, because as we install more and more renewable energy, as I mentioned earlier, our system is going to get, or our power generation is going to be more and more intermittent. Our system is going to be very dynamic. We have to be able to react to this. But that is not the only case, right? We also have issues with faults. Now, for example, I'll do this very quickly because I'm almost out of time. You remember in 2020, in August, there was an issue where there was an island-wide blackout. So what happened was at Kerala power plant, there was a 3-phase to ground fault that happened. This trip off Kerala and also a sudden spike in frequency tripped off Lakvijay, which is the Norachole coal power plant as well. And then these are 2 major power plants. Right? So we lost about 810 megawatts, and then the system frequency dropped. And this caused a cascading effect where all generators around the island started to trip off. So island-wide, we lost power. Okay. So without a grid connection, the Lakvijay power plant went into full shutdown mode. So that will take several days to restart. It took 6 hours to restore the energy, right, to the system. And this was partially done because they didn't know exactly how much power was connected. So when they tried to connect to high power loads, the generator would shut off again. Okay. So how the PMU system have prevented this? We can only do a speculation here. Now, of course, the first 2 parts we cannot prevent. So up to tripping off Kerala, that's a human factor. That's a human error. We cannot prevent that. That happens. Okay. The tripping of Lakvijay probably would not also be possible to prevent because it happened instantly. But now, this 810 loss, we know about this. PMUs would tell us, okay, we lost this much power. Within seconds, it would calculate. It lost this much power. Let's start load shedding. Let's turn off critical loads. Let's turn off some cities so that the system-wide, we don't go into a shutdown. We can start islanding. You can take all these decisions very quickly, not humans. The computer itself, AI systems would take these decisions based on this very accurate PMU data that is available, right? It can take decisions to prevent an island-wide shutdown, right? Now, for example, this Lakvijay needs a power connection. Although it is disconnected, it still needs power to not go into a full shutdown. So this can also be stipulated in the PMU algorithms, where it will be still provided by a small amount of power so that it doesn't go into full shutdown mode. That takes many days to restart. So even the power that is lost would be lost only in small isolated areas, so it will be easier to restore. And this issue of not delaying the restore because they didn't know how much power was connected or how much load was connected, that again could have been solved because PMUs would know exactly pre-fault, before the fault, how much power was or how much load was connected. So you can use that information for very good restoration analysis. That's another part that PMUs can help with. So all these things are there. And as we go further and further installing more renewable sources into the system, the necessity for PMUs is going to only increase. So the incident, could we have prevented it? No. But the outcome, this island-wide shutdown that lasted for hours, now of course that doesn't seem too bad as with what we are going through, but things like that can be prevented. Okay, so we're almost out of time. So just in conclusion, PMU networks are essential for future grids, right? They allow the grid to be flexible with load and generation changes. They make the grid highly reliable. They make it efficient because you know exactly how much power you can send through a line. You can make maximum use of these lines. You give very good observability, so you can make good decisions, right? So it's part of the smart grid initiative. Okay? So thank you very much. And if you have any questions, we have, I hope I just went a little bit over time, but I hope we have some time for a few questions.
Participants, now it's the chance to clarify any doubt you may have about PMU. You can either drop your concern or question in the chat or direct them to Dr. Anton by unmuting yourself.
So seems like we don't have any questions. Right? Hopefully, by joining through to the workshop, you can get a lot more information. We go into more detail because this is just a superficial like issues or the applicability of PMUs, and you'll dive deeper in the workshop series.
Yeah, so it seems all clear and no questions up to now. And join with our PMU Design and Applications workshop series to learn more about PMUs from fundamentals to a deep dive in the subject. Thank you, Dr. Anton. Your insights have been absolutely wonderful, and I would like to thank you all for being a brilliant audience and hope you got something new. Once again, thank you very much, sir. We are really fortunate to have your knowledge shared with us today.
We are so today on very much Dr. and please accept
We are so grateful for your time, sir, knowledge, and expertise you shared with us today. So once again, thank you very much, Dr. Anton. And please accept this digital token of appreciation.
Thank you. I enjoyed it very much.
I hope our participants are really excited to know about what is going on throughout this project. And so what is next about Anusha?
Yes, Devandi. Here we have someone special to handle this better than us. To give you an introduction about the PMU Design Workshop Series and competition organized by Y2N Pro in collaboration and partnering with Ieee, Sri Lanka Chapter, Young Professional Global. I would like to invite the chairperson of PES Sri Lanka, Dr. Sudhir Navaratna.
Dr. Sudhir Navaratna is a senior lecturer in the Department of Electrical and Electronic Engineering, Faculty of Engineering, University of Ruhuna. He received his bachelor's from Faculty of Engineering, University of Peradeniya in 2007, specializing in electrical and telecommunication engineering. After moving to USA for his postgraduate studies, he started specializing in smart grid and related areas. Dr. Sudhir Navaratna completed his master's in 2011 from Purdue University, USA, with a focus on advanced metering infrastructure and its security. He received his PhD from Purdue University in 2016, and his area of interest include smart grids, microgrids, distributed energy resources, and the use of multi-agent system in smart grids and microgrid applications. So please welcome Dr. Sudhir Navaratna to the spotlight. Doctor, over to you, sir.
Hello, am I audible?
Yeah. Sir.
Okay.
Yeah.
So yeah, thank you, Sevandi, for nice introduction. I'm experiencing the power cut at the moment. My connection is unstable. Then I will turn off my video. Okay. I think. Okay. Yeah, I will share the screen.
Yeah. So you can.
Okay. I think you can see it. Yeah, so again, thank you for the nice introduction. I have to make a very small correction, Sevandi. I'm currently working in University of Peradeniya. And I also graduated from University of Peradeniya. That's okay, perfectly fine. So first of all, I would like to thank Dr. Anton for his very valuable presentation. I think that will give you a lot of insight on PMUs and its applications, and how a little bit of theories and things that associated with the PMUs and with that, I also noticed that there were no questions at the end of the presentation. So typically in my lectures also, I said there is two things that can happen. That means either you know very well, or either you don't know it much. Okay, so being this technology is new to our country, I believe that your knowledge on the PMU is a little bit at the. If you go through this workshop series, you will be definitely able to boost this, and at the end of the workshop series, you will have many questions, and you will develop the unique workshop series and design competition. which are organized by the IEEE Y2N Pro, who is actually the part of the IEEE YP Sri Lanka section, Sri Lanka. And then the we collaborate with the IEEE Power and Energy Society, Sri
Hello, Dr. Sudhira. You are not audible, sir.
sorry, I think I got disconnected. I will turn off my video. Can you all hear me?
Yes, sir.
Okay, yeah. So let's first take a look at the what's this IEEE and and all these subset, all these chapters and the the IEEE.org. You will you can get a lot of information on this about the IEEE, the Institute of Electrical and Electronic Engineers. So what is this IEEE? So according to their terminologies, the IEEE is the trusted voice for engineering, computing, and technology information around the globe. So IEEE is the world professional organization dedicated to advancing the technology for the benefit of human community. So IEEE, they conduct a lot of conferences, and they have a lot of journals and highly cited publications, and they develop technology standards and then the professional and educational activities. So you can get a lot of information if you join the IEEE. The IEEE covers many areas, and the power and energy is just the part of it. You will see in the later slide, so how this Power and Energy Society is associated with the IEEE. So the quick facts about the IEEE. So you can see that there are over 409,000 members in more than 160 countries. More than 60% from whom are from the outside the United States. Okay. So there is, this is a vast spread community, and with many voluntary activities and voluntary services, and they have, work collaboratively, achieve a lot of. So in this IEEE society, you have more than 125,000 student members, and then you have 343 sections in 10 geographic regions. 15 chapters, okay, and you have 3,565 student branches, okay, at colleges and the universities spread over. About the IEEE Power and Energy Society, we also have in a couple of universities in Sri Lanka as well. So, and also you have 608 affinity groups, young IEEE young professionals being one of them, and the other woman in engineering, which is most popular. And there are so many other affinity groups as well. So if you, so these are the regions that I was talking about. So you have 10 1 to 6 is within the United States, and we are falling in region 10. So Sri Lanka is belonging to region 10. So we closely work with region 10 groups in our many activities. So this is the, how the chapters, affinity groups, and sections are organized. So you have the regions, and under regions you have sections. And so for an example, if you get Sri Lanka, we are belonging to R10, and our section is actually one and only section is the IEEE Sri Lanka section. So everybody else, all the chapters, affinity groups, and the student branches comes underneath the IEEE Sri Lanka section, and they report to IEEE Sri Lanka as well. So the one of the chapters actually the organizing this event is the IEEE Power and Energy Society Sri Lanka chapter, and you have many other chapters. You have a robotic automation chapter and the microwave chapter, and there are many more for different fields. Okay, and then the affinity group, we have IEEE YP Sri Lanka organizing this event, one of the affinity groups, and the IEEE Y2N Pro is part of this IEEE YP Sri Lanka affinity group. So that's how all this, the IEEE system is built up, and so you can see that we all work collaboratively in different activities. So we have our own individual activities as well as collaborative activities to improve our reachability in Sri Lanka as well as sometimes throughout the world. So sometimes we organize activities collaborative with the other part of the world as well. So you will see some examples later. So, so why we should take the IEEE membership? Okay? So you can join the IEEE as a professional member or student member. So there is a member fee associated with that. And some institutes provide the memberships through various fundings. For an example, in University of Peradeniya, all the Department of Electrical and Electronic Engineering are part of the IEEE, and they are funded by the PG program of the Department of Electrical and Electronic Engineering. So likewise, you can arrange the ways for your membership through your university or through your company. Okay, and so the benefits that you get by joining the IEEE, the major one is to build your network with other technology professionals in Sri Lanka and in the other part of the world as well. And then you can establish a professional profile highlighting your accomplishments. So you can knowledge, and you can be volunteer, and you can distribute your knowledge. You can, like for example, like as Dr. Anton does, you can do presentation, and you can distribute your knowledge, and you can also gain knowledge by participating in many discussions and various technical activities. Okay? And and you can also discover the many events happening throughout the world in region 10 as well as the other region by going to the IEEE website. And as a member, you can sometimes get free pass. Sometimes you get reduced registration fees for these activities. And also you can publish in conferences, and when you go for the conferences, some reduced rates for IEEE members. So those are some benefits, but not all, that you can get as an IEEE member. So talking about the Power and Energy Society Sri Lanka chapter, which comes under the IEEE Sri Lanka section. So if you go to this www.ieepes.lk, that's our website. So you can get information about the activities and things we do. Okay? But before you go to the Sri Lanka chapter of the Power and Energy Society, we are falling under the, we are working with the main chapter or main society, which is called as the Power and Energy Society. So it provides the world's largest forum for sharing the latest in technological and development in electrical power industry. Okay? So they participate in developing standards and the guidelines and so on, and then they also publish documents, and you can, as a member, you can navigate through them and you can enhance your knowledge. Okay? So these are some of the benefits as IEEE PES member, not like as IEEE PES Sri Lanka chapter member, but as IEEE PES member. The nice thing here is, like, once you became an IEEE member, you become a member of the IEEE Sri Lanka section. So you don't have to pay extra to become a member of the IEEE Sri Lanka section, but you have to pay to become an IEEE member. So once you become an IEEE member, you can become members of any societies that you are interested, depending on your interest as well as the amount you can spend for the membership. Okay? But there are so many discounts available for many countries and for students and so on. So you can all get all those information when you go to the IEEE the website that I talked earlier. So the benefits, and if you once you become the IEEE PES member, you automatically become the member of the IEEE PES Sri Lanka chapter. So all the benefits that you get from the IEEE PES membership, you will get as IEEE PES Sri Lanka chapter member. Okay. Of the benefits are you have access to what they call the PES University, which offering many knowledge of the education. They have a lot of webinars, web-based tutorials, the talks about electrical and power systems, and many other courses. So you get access to all of these. Some are free and some are the reduced price. So you can enhance your knowledge by going through this context. And then you have the IEEE PES Resource Center, which gives you access to many technical documents, conference presentations, video tutorials, then the webinars and many more. Okay, so same scenario applies there. So you get some for free and some for reduced price. Okay, and you will get the IEEE Power and Energy magazine for free for every month. And then you have this PES e-bulletin for the latest PES news and activities delivered twice. So it will be delivered twice a month. So you will get all the information about the activities held around the world. And if you're interested, then you can go ahead and participate with. So those are some of the benefits that you get as an IEEE PES member. So then being IEEE PES Sri Lanka chapter, so you will automatically become a member once you become the PES member. So this is this PES Sri Lanka chapter is one of the most active chapter of the country. So we have many volunteers working together, and we are organizing many events for IEEE PES members, as well as the specifically targeting the students who are not IEEE members, and sometimes not sometimes most of the time the industrial participants as well. So we have worked collaboratively with them. We have organized many events which are helpful for industries to enhance their knowledge, and also we get the knowledge of the industry people and to how because we need to sometimes fill the the gap between the industry and the academia. So we work collaboratively with the industry as well as the academia in holding these activities. Okay, so we have members, as you heard at the very beginning, from the students, academics, and researchers, as well as the electrical engineers in industry. So we have PES student chapters in University of Peradeniya and University of Moratu and many other universities as well. I think SLIIT as well. Okay, so being a member of the IEEE PES Sri Lanka chapter, you also get added benefits. So we organized technical talks. Okay, so these technical talks that we organized last year, you can see the digitalization of the power grid and the integration of the renewable energy on a large scale. So we get and if you look at the resource person, so one is from Australia and one is from Sweden. So we get the resource persons all around the world, and we give the latest knowledge on the latest technology to our IEEE PES Sri Lanka chapter members, as well as some non-members as well. And we organized international events. So this the first one is the one that organized last year with is called the humanitarian contest, and so this was organized with the international group. And then we have this year actually SLTech for students. So this is the Sri Lankan Power Engineering Conference. So most of the undergraduate students, as well as the the postgraduate students, they do a lot of the final year projects and the research work. So to publish, to do the initial publication on their work, we have opened up a conference called the Sri Lankan Power Engineering Conference. So as a student, so as a postgraduate student, you can participate in this power and energy conference as well. So which will be held in every year. And there are awards like presented by the IEEE Sri Lanka chapter. And if you work collaboratively with the IEEE as an industry young professional, you may be also eligible for these awards as well. So and then we also have some fun activities like family get together. Unfortunately, due to the prevailing situation in the country, we couldn't help this for a couple of years, but we are eager to help this as soon as possible once we get the pass. So all the IEEE PES members and their families join together, and we can enjoy and share our knowledge, share our experience, and and do some fun activities in this family get together. So those are some of the benefits that you get being an IEEE PES Sri Lanka chapter member. Okay, so I think now you have some idea about what is this IEEE, and I think you have given an idea about what is the IEEE young professional is, and then now you have idea how you can join them and how you can work with them, and to be members in these chapters and the affinity groups, and sometimes section not sometimes the sections and subsections, all are volunteers. So they are all volunteers to share their knowledge and get the improve their knowledge, and get the knowledge from all around the world, and distribute it to the the members as well as the other. So that's the vision of the IEEE and IEEE chapters and sections and subsections. So okay, so I think you have some idea about IEEE. I will invite you to, if you are not a member of IEEE yet, I will invite you to be a member of the IEEE and IEEE PS and IEEE PS Sri Lanka chapter, and work with us very closely to the betterment of the future. Okay, so with that, let's move to the important part of this talk. The previous one is also important part of the work. Let me see that. Okay, oops. Sorry, so let me share it again. What happened? Just want to see the time, and now I lost the sharing. Okay, so I hope you can see this. Let's talk about the PMU workshop series and the competition in very brief, and I think you will get some knowledge about this in the presentation as well. So what is the workshop coverage? Okay, so you have a PMU workshop. We background behind the phase measurement unit and the associated technologies, because if you went through the Dr. Anton's presentation, you might have seen that it's not just a single device, but it's a devices that work together, network together to give you a lot of data, and then there's a lot of data analysis part, and there are so many other components in this related to the PMU. So you will get some theory, practical knowledge on the PMUs and the associated components. Okay? And you will get some practical knowledge about how analyzing this PMU data. I think Dr. Anton talked about the recent blackout in the Sri Lanka in 2020, August 17, 2020. So we are hoping to give you some experience on what if the PMUs were there. And use some softwares to analyze the situation, knowledge about the PMUs. And then we have the design competition. So I will give you a detail about design competition at the end of the presentation. So in theory, we will cover the PMU basics and the PMU applications, as well as the PMU development. So we all works together. You get the theoretical knowledge, you get the practical knowledge, and you participate in the competition. So you can help to improve the algorithms used PMU by participating in this competition, which was the requirement came from the University of Manitoba in Canada, from a professor who is a member of the SLIIT, which is they are building a standards for the PMUs and so on. So the request came from them. So it's very practical. It's not a hypothetical thing. Very practical, very the timely requirements. So by participating in this competition, you can give your knowledge. You can use your knowledge, improve something which is very widely needed. Okay, so the outcome of these workshops and in the competition is to improve the theoretical knowledge of the PMU design, identify the applications of the PMUs, then identify the future trends for the PMU applications, and to gain the hands-on experience on design and development of the PMUs using conceptual simulation, because at the moment we don't have access to the real hardware, as Dr. Anton says. it's very core. And we have a working group in Sri Lanka working on these PMUs. Dr. Anton and I are part of that. And so there are expertise from different universities around the Sri Lanka. And we were looking for building some simulation, simulation platform. But the cost is the one factor that we have to the case. So this is the syllabus. I think you will get more information about the syllabus in the applications and the future of the PMU. So we have allocated a couple of lecture hours, and then you have the quizzes and some simulation components where you will be evaluated and you will be presented certificates at the end of the workshop and the competition. Okay. So talking about the resource persons to cover the introduction to PMU part, we have invited the Professor Atula Rajapaksa from the University of Manitoba, Canada, at the Department of Electrical and Computer Engineering of the University of Manitoba. So I'm not going to go into all the detail of his bio. And you can see that he's one of the members of several IEEE and SIGRE working group, the convener of the SIGRE IEEE joint working group C4 C2.62 on review of advanced in synchrophaser technology and application. So he's one of the professors who gave the idea about the competition and gave the the requirements of the competition. Okay, and then we have Professor Janaka Ekanayake. I think many of you knows him very well. So he professor in University of Peradeniya, Sri Lanka. And he also worked as a visiting professor in the Cardiff University, UK, and the University of Tenaga National, Malaysia. So he's with the many expertise, many we have participated in many conferences as keynote speakers, and so you will get some information how the PMUs can be utilized in Sri Lankan network to improve our visibility and improve the quality of the power in Sri Lanka from his voice. And then we have Dr. Prasad Waduvage from University of Moratuwa, Sri Lanka. So he will be on a face measurement application. And we have Dr. Anton Hettiarachchige. I think you have heard from him today, but he might also come in future talking about the face applications as well. And then we are working on still to be confirmed one person from the USA and one person from the UK, one from the industry as well, to talk about the future of the PMU, because now they have, as Dr. Anton says, this thing started like 10 years back. So now they have come into very expert levels and of the. So it's, I think, best to hear from the the rest of the world rather than from here about the future of the PMU. So we are working with them still to be 2% to talk about the future of the phase management. So okay, so that's the brief of the workshop and then the resource persons that we have. The panel, I think you might have experience with some of them and get very interesting knowledge and interesting talks about PMU and their applications as well as the future of the PMU. Now, for our competition participants, so we have a challenge for our competitors. So the challenge is to develop an algorithm to measure the frequency and the rate of change of frequency. So if you follow the Dr. Anton's presentation, he has mentioned that there are many measurements that taken from the PMU. One of them, phase is another one, and then you have the frequency, and then you have the rate of change of frequency. And Dr. Anton also said the measurements of the PMU depends very much on the frequency. Then you have a issue in the issue in the error of the this measurement. So how you track this frequency very correctly, and then also the rate of change of frequency is very important in a rapidly changing environment. So your challenge would be to develop a novel algorithms that will tackle this problem. Okay, so there are so you have to implement these algorithms. Maybe you can start with the conceptual thing, and then you can implement it in a software or any hardware platform that you are very much familiar with. It's up to you. We are not going to do that. You should use this platform, but any platform you have to implement that algorithm, and you have to prove that this algorithm works according to any given accuracy, delay, and other specification. For an example, the specifications include the maximum processing delay of 60 minutes. Means within a 3 cycle of the nominal frequency, you have to give the values of this frequency and the rate of change of frequency, and then every 3 cycles you have to update it, 3 or less. So the maximum processing delay is 60 milliseconds, and the steady state accuracy in the of the frequency and the rate of change of frequency should be in this given value. For an example, frequency error should be less than 0.005 hertz. So you can see how critical these things are. And the rate of change of frequency error should be less than 0.4 hertz per second. So this should be valid for all the frequencies ranging from 48 hertz to 52 hertz. Okay. And then the accuracy must be maintained under a presence of the harmonic with the 0.2 distortion and 1% of each harmonics up to 20th harmonic with the input voltage within the 20% of the nominal voltage. So that would be the measuring voltage. So Dr. Anton says like how these measurements are taken. You have current transformers and voltage transformers. So through that you step down the voltages and currents, and then you input that into the PMU. So that's talking about that reduction of voltage. Okay, so you can see this is a pretty serious stuff and very interesting stuff. Very realistic and very application oriented. So you will have a lot of fun and a lot of experience developing these algorithms. And then also the accuracy under amplitude and phase modulation test with the modulation frequency of 2 hertz and 10% magnitude. Hello, can you hear me?
Yes, sir, we can hear.
Yes.
Where did I drop? Hello. Hello. Can you still hear me?
I can hear you.
Yes, sir, we can hear you.
Okay, sorry about all these hassles going on. So I will the competition, and so let's get started from this point onward. So and give you knowledge to enhance the algorithms of the PMU through participating in the PMU competition. So with that, I will conclude my talk. So if you have any questions, you are welcome to ask. So over to you, Sevandi.
Okay, dear Dr. Sudhira, I hope now the audience have a clear idea about the workshop series, speakers and competition. If you require further clarifications, you can raise them up at the end of the session. On behalf of Ieee Young Professionals Sri Lanka, Y2N Pro Project Organizing Committee, I would like to extend my sincere appreciation for Dr. Sudhira. So Sevandi, what areas are we going to cover in our PMU design workshop series? Can someone who has no idea about the PMUs join us?
Of course, Anusha. When it comes to the course content of the PMU design workshop series, it is designed to cover both theoretical as well as practical aspects of PMU. Furthermore, the complete course content is planned in such a way that it begins with the fundamentals and progresses to a deep understanding of the subject, providing the complete knowledge needed to become a professional. To present the course content of the PMU Design Workshop series to you, I would like to invite Ms. Rumesha Patirana.
Rumesha is a professional in marketing and content creation. She is an alumna of Pme University of Sri Lanka and the University of Colombo School of Computing. She has been volunteering with IEEE since 2016 in both national and regional projects, events, and societies. Rumesha is the Syllabus Resource Group Coordinator of the Y2N Pro team. Ms. Rumesha, over to you.
Thank you, Sevandi and Anusha, and good morning, everyone. I hope you all can hear me clearly.
Yes, we can hear you.
Okay, so let's start. So when you think about a workshop, what would typically come to your mind is someone would actually organize a workshop and then others would take part in it, and at the end of it, everyone will go their own ways and end of story. But with Y2N Pro, what we're trying to do is to take things a step further and create a community of like-minded individuals who are interested and will actively get involved in the niche area that we are exploring. So simply put, what we are offering here is a comprehensive course in the niche topics, starting from fundamentals to deeper subject matters, which will hopefully be the foundation or the stepping stone for young professionals or future young professionals like you all to be an expert in the field. So I will give you a brief idea of what the course looks like, followed by an overview of the topics that you are planning to explore. So the workshop series we have planned on design and applications of facial measurement units is aimed at delivering a thorough knowledge of PMU design and development for conceptualizing solutions for power grids. We have identified 3 learning objectives to this end, namely understanding the fundamentals of PMUs, learning about practical applications of PMUs, and finally investigating objectives, and each workshop is going to be followed by a quiz aimed at evaluating your level of understanding on the discussed topics. And additionally, there will be 2 evaluations relevant to the competition that we're doing at the end of the course as well. And also, we will award you a certificate after successfully completing these workshops and evaluations. So moving on to the actual workshops, the first workshops are designed to introduction to PMU 1 and 2 from and Professor Janaka Ekanayaka from University of Peradeniya. These are aimed at helping you get a solid footing on the basics. So even if you don't have a background on PMUs, you can still get an understanding and move on from these initial workshops. And the third workshop will be on phasor measurement applications, and it will discuss topics such as power system control and protection, and power system modeling and verification using synchrophasor measurements. So this workshop will be conducted by Dr. Prasad Vardurge from University of Moratuwa, and also our keynote speaker today, Dr. Anton Hettiarachchige. And the fourth workshop will be conducted by on the future of PMUs, covering topics such as measurement-enabled power system automation and PMU applications and smart grids. So the fifth and final workshop will be a demonstration session by, again, none other than our keynote speaker today, Dr. Anton Hettiarachchige Don from the Sri Lanka Institute of Information Technology. So in order to complete this course, it is necessary that you attend all the workshops and complete the quizzes at the end of each workshop. Due to the prevailing situation in the country, we are conducting all the sessions online except for the where we hope to give you all an opportunity to get there. Sorry about that. Together and get an opportunity to meet everybody and network in person. So to make things more interesting and keep the momentum going throughout the course, we have added the design competition to the mix. And this will start at the end of the second workshop, and it will involve developing conceptual solutions involving PMUs. Which I will elaborate on in a bit. So the competition has 2 stages, and in stage 1, you will submit a proposal, which we will shortlist during the mid-evaluation, and only the shortlisted proposals will go forward in the competition. And once you're shortlisted, you can work on your simulations and showcase them at the physical event, which will take place on 2nd of October 2022. And your simulations will be evaluated and winners will be chosen by a judge panel. And on the same day, we will also award your course completion certificates and the prizes for the competition winners in a grand ceremony. And since we start the competition right after the second workshop, you are inevitably going to have a lot of questions that need to be answered relevant to your case studies. And you can prepare these questions in advance and ask them from the speakers during the next workshops, who are automatically your mentors for the competition. So if you're taking part in the competition, it is also necessary that you take part in the workshops for this reason. So the registrations for the workshops and the competition will start soon after, and there will be only one registration form for both the workshops and the competition, with options for you to select how you would like to participate. So for example, you might be interested only in taking part in the workshops and the evaluations only. So then you can select the relevant option on the form. So if you're taking part in the competition, like I said, it is mandatory to take part in the workshops as well. So if you're registering for the competition, one option you have is to register as a team of 5 members. So the team lead should be the one to fill the registration form, and we will randomly assign 2 additional members to your team afterwards. If you do not have a team, you don't have to worry. You can just register by yourself, and we will be assigning you to a team afterwards. So I hope you have a pretty clear idea about how the workshops and the competition are going to go and what we are trying to achieve through it. And I really hope that you're excited to be a part of this project and are looking forward to seeing you all at the workshops and the competition. If you have any questions, you can reach out to our team during the Q&A session, or afterwards, we will be able to help you with clarifications. So thank you. Over to you, Anusha and Sevandi.
Thank you, Ms. Rumesha. The course content of the program was clearly presented by Ms. Rumesha. I hope now our audience has a clear idea about what are the areas and how we are going to cover them in our workshop series. Thank you very much for your explanation again, Ms. Rumesha.
Here now, it's the last chance to clarify any doubts you have about the program. You can either drop your question in the chat or raise them up by unmuting yourself.
Audience, do you have any questions regarding the competition, or how we are building teams, or how to register, or what will be happening on the competition evaluations like this? We received one question, how to get the register application. We will be starting the registration from tomorrow onwards. So we hope that to share the register application to all the awareness session registrants via an email. And also, if you join the WhatsApp group, we will be sharing it in the WhatsApp group, and also the social media channels that we have shared in this chat. Please like and follow them up. You will see the updates of the each and every events and the registration via the social media. If you don't have any questions, we can move to the next session.
Okay, I think that is for the Q&A. We can move on. But if you got any doubts, you can reach the Y2N Pro team anytime. So at last, Dr. Anton Hettiarachchige and Dr. Sudhira Navarathna, we are truly grateful to have you today and especially sparing your valuable time. Every good thing comes to an end. We are now approaching the last few minutes of today's program. To deliver the word of thanks, I would like to invite Ms. Supivi Gunatilaka.
She's a second year undergraduate of Business Information System in University of Westminster, UK. Supivi is a director of IEEE Computer Science Technical Chapter of IIT, and she is a program and logistic team member of Y2N Pro. Over to you, Supivi.
Thank you, Anusha and Sevandi. Good morning, ladies and gentlemen. On behalf of IEEE Young Professionals Sri Lanka Y2N Pro Project Organizing Committee, it would be a great honor to me to deliver the word of thanks. Our Y2N Pro target is to provide the needed expertise and knowledge to niche committees in various industries. As a second program of Y2N Pro, we organize the workshop series and competition on pressure measurement unit of power system engineering. I hope today's session gave you good knowledge about pressure measurement units. As you know, every end is a new beginning. We have planned to provide you with knowledge of the theories, design and application of PMU through our workshop series. Not only that, you can have a chance to participate in PMU design competitions and win the valuable prizes. You can get your application and appreciations and prizes at our physical awards ceremony. So don't miss this valuable opportunity. If you want to know further details about our workshop and competitions, you can connect with us to YP Sri Lanka and PES Sri Lanka social media platforms. First, we would like to give you all a big applause. Thank you all for participating in awareness session. You all are our biggest strength. Now, I would like to give my deep sense of appreciation to Dr. Anton Hettiarachchige for spending your valuable time educating the audience on PMU in electrical engineering. Further, we are grateful to Dr. Sudhira Navarathna for his brief explanation of Power and Energy Society introduction and involvement and for sharing his knowledge with us. And I would like to thank our Vice Chair, Mr. Pme Dasanayaka and Ms. Rumesha Patirana, who gave introduction about Y2N Pro and Y2N Pro course content. I would like to pay my heartiest gratitude to Dr. Akhila Vijayatunga and Mr. Ashan Bandara for supporting and encouraging us by giving their immense support to conduct this event successfully. My special thanks goes to Executive Committee members of the IEEE Power and Energy Society, Sri Lanka chapter for partnering and collaborating with us, and the IEEE Power and Energy Young Professionals Global for collaborating with us by granting the IEEE PES Ignition funding. IEEE PES Student Branch Chapter and University Coordinators, thank you all of you for collaborating with us. Finally, I would like to take this opportunity thanks to our Vice Chairwoman of Y2N Pro, Ms. Kaumudi Gunatilaka, and all of the organizing committee members and all the volunteers of the Y2N Pro and YP Sri Lanka, who are the real giant behind this scheme and made this occasion a great and huge event. Because the success of an event like this cannot happen in overnight. Last but not least, I don't think that I could give enough thanks to all of you and in this moment, limitation of time. But thank you so much for each and every one of you joining us and being so supportive to grace this occasion as a more successful one. Thank you and have a nice day to you all.
Thank you, Supipi. Hope you all are now aware of the PMU Design Workshop series and competition organized by Y2N Pro.
The debate is over. Let the countdown begins. Now we share the registration links in the chat and on all social media platforms of ours. Don't wait till the end. Hurry up, team up with your peers, or individually you can register with us. We will close the registration process once we gather the niche crowd.
Click the registration link and do register with us for the PMU Design Workshop Series and competition organized by IEEE Y2M Pro, partnering with IEEE PEST Sri Lanka Chapter and IEEE PEST Young Professional Global. We will inform you of further details via email.
With that being said, we can conclude today's proceedings. We are Y2N Pro IEEE Young Professionals Sri Lanka. Don't forget to follow up on Facebook, LinkedIn, Instagram, and YouTube.